Today we're using Hess law to determine an enthalpy of decomposition. So we need to look at decomposing potassium hydrogen carbonate forming potassium carbonate. Now we can't measure this enthalpy change directly because to carry out the thermal decomposition we're going to have to blast our potassium hydrogen carbonate with heat. So there's no point putting a thermometer in there as well because we're not going to be able to measure the temperature change. So what we need to do is have a look at two different reactions that we can then link together with a Hess cycle. So what we're going to do here is use the reaction of each of these with hydrochloric acid. So you might like to think to start with what the products will be if we react potassium hydrogen carbonate with hydrochloric acid, and what the products will be if we react potassium carbonate with hydrochloric acid, and how that might link together in a cycle. Okay. Now, in order to help ensure that you can carry out the calculations later on, right at the end of the video, I will give you the cycle, but I want you to have tried to create it first. So just use that as a check if you need to at the end. So in terms of our reaction, or our reactions, our experimental data here, what we need to do is use a burette to measure 30 centimeters cubed of hydrochloric acid. Okay, so I did that earlier. So here's one I made earlier, Blue Peter style. So I'm going to pour that into the polystyrene cup there. I'm going to weigh between 2.5 grams and 3 grams of the potassium carbonate that I have got here. And then we're going to record the temperature of the acid. So I'm going to tip this on the side slightly to make sure the bulb of my thermometer is fully submerged because we don't have a huge amount of acid in there. And then we have our accurate thermometers here as well. So these have graduations to the nearest 0.1 centimetre cubed. So we can use these to then read 2 decimal places, with the second decimal place being a 0 or a 5. So I'll keep an eye on this and establish a starting temperature. The results for this are in a photograph at the end of this video as well. So once we've done that, we then need to add the potassium carbonate to the acid. Think about what's going to happen, and we're going to stir carefully with the thermometer and record the maximum or minimum temperature reached. So we want to end up with our biggest temperature difference. So hopefully that fizzing that you can hear is no surprise there. So you can have a quick look in there. There we go, fizzing away. You put you back down here. Okay, and then I'm just monitoring the temperature. So it's going up here, and I just keep an eye on this until we get the maximum temperature reached. And as I was saying before, these are going to then be recorded in the photograph at the end of the video. So this one has gone up to about 22 there. Just monitoring. So it's bang on the 22 line at the moment. And then it's stopping, I think, and starting to come back down. So I would be recording that one to 22.00 degrees. So it needs to be the 2 decimal places with those 0.1 centimetre cube graduations. So part 2 of the experiment is just to repeat the same thing, but with the potassium hydrogen carbonate. So I won't make you watch me do that. So you then need to have a suitable results table and to note down the readings that are given at the end of the video, and then work through your results, calculating the enthalpy changes for the 2 different reactions. So in the same manner as we have done with the enthalpy of neutralization experiment and the magnesium in the hydrochloric acid experiment using our temperature change. So work out the enthalpy changes in kilojoules per mole and then link these together in the Hess cycle. If you're stuck on the Hess cycle, as I was saying before, there will be a photo of that right at the end of the video, but please save that for just if you're stuck. Okay, you can crack on with your write-up.